Hi, so I want to work through a couple of these inverse trig integrals that require a u sub. So the first one I'm going to do is this dx over 1 plus 4x squared. So we kind of have to recognize the pattern. So this is similar to, right, du over 1 plus u squared. I could have made that an a squared. I wish I would have a squared. This leads to an inverse tangent. So let me show you a little bit of why, because if you'll believe this why, then I can show you the u sub part over here. Okay, so if we're just going to prove this a little bit right here. So we're going to integrate du over, broken pen, 1 plus u squared. Okay, so we do this with a u sub, trig sub. So I'm going to let u actually equal tan theta. So then du is going to be secant squared theta d theta. It's on screen. Okay. So I'm going to go ahead and make those substitutions. So du gets replaced with secant squared theta d theta. U gets replaced with tan, so I'll have a 1 plus tan squared theta on the denominator. 1 plus tan squared theta, that's secant squared theta. So I have a secant squared theta on top and on bottom, so that's just going to be integrating d theta. So that leads to theta, right, back up here. So now to get back to u's, I would take the inverse tangent of both sides here. So theta equals, right, the inverse tangent of u plus c. That's where we get our, right, antiderivative. So to do that with dx over 1 plus 4x squared, the first thing we're going to do is recognize that 4x squared is 2x quantity squared. So I could think of this, right, dx over 1 plus 2x quantity squared, and then we would do a u sub on this one. So I would let u equal 2x, which means du has to be 2dx. So grab a color. That means I need a 2 here with my dx so that I have du, which means I need a 1/2 out in front so that I'm balancing that 2. So my new integral in terms of u is going to be the 1/2 that we balanced. 2dx gets replaced with a du. My denominator is going to be 1 plus u squared, right? But we just determined that if we integrate that, I get, right, the antiderivative is the inverse tangent of u, but u is 2x, so we want to get back to the letter we started with. So my final answer is going to be 1/2 inverse tangent of u, which is 2x, plus c. Okay, so the next one I want to do, it's dx over the square root of 4 minus 25x squared. Okay, so again, we're kind of looking for what does this feel like? And this feels like, hopefully, an inverse sign, right, antiderivative. So let's go ahead and verify this, right, du over the square root of a squared plus, or a squared minus u squared. That antiderivative is inverse sine of u over a. So we're going to verify. So we're going to go back to our integral. And now we're going to let u equal a sine theta. Okay. So du is a cosine theta d theta. Stay with me. It's like, why would we do that? Because I know it's coming up, right? So now swapping everybody out, my du is going to be a cosine theta d theta on the denominator. So we're going to do some trig down here. So I've got a squared minus u squared. So that'll be minus a squared sine squared theta. Okay, some trig and some algebra. So a squared minus a squared sine squared theta. So you can imagine factoring out that a squared. So just a little denominator work here. So if I factor out the a squared, I would have 1 minus sine squared theta. Right? And 1 minus sine squared, so just to make sure I get my sign in the right place, right? So here's your Pythagorean identity from trig class. So if I subtract sine squared from both sides, that'll tell me that cosine squared equals 1 minus sine squared. Okay. So this 1 minus sine squared is really just cosine squared. So that denominator is actually going to be the square root of a squared times cosine squared theta. Yay, right? Perfect square, multiplying. I don't have any pluses or minuses. So this integral is actually going to be, right, a cos theta over a cos theta d theta. So again, we're integrating just d theta, which equals theta, right, plus c, but we'll get back there. So now that's what theta equals. I need to get back to, right, u's. So my original was up here in terms of u and a. So here was my substitution, right, u equals a sine theta. So u equals a sine theta. So sine theta equals u over a, or theta equals, right, the inverse sine of u over a. Just what I had. Cool. So as long as you believe that and can make that true in your head, then I can replace this integral here. Right? So I'm going to write it in dx one more time. So I have dx over square root, and then I have 2 squared minus 5x quantity squared, right? So we can see our a, and we can see our u. So this antiderivative is the, oh, hold on. If that's u, I have to do a u sub, don't I? So now we're going to let u equal 5x. So du equals 5dx. So back up here, right, I've got the dx. I need the 5. So a 5 inside there, a 1/5 outside for balance. Okay, now I'm going to rewrite my integral in terms of u. So 1/5 integral. There's my du on top. Inside there, I've got 4 minus u squared. Okay. So this equals 1/5 inverse sine u over a, right, square root 2. But then from u's back to x's. So final answer, 1/5 inverse sine 5x over 2, right, plus c.